Good morning, everyone. We will be going to start virtual labs workshop within 5 minutes.
Hello.
Mic check.
Please. A very good morning to all. I welcome you all for today's virtual lab session. Sir, shall we start? Pratik sir?
Yes, ma'am, we can start. I hope I'm audible.
Yeah. Yes, sir.
Okay.
Thank you, sir.
So, thank you, ma'am. So, good morning, everyone. Welcome to today's session on Virtual Labs. So my name is Prateek Sharma, and today I'll let you know about this particular platform that is Virtual Labs. Now let me tell you how this particular session will proceed. So first of all, we'll see a small presentation, and with the help of that presentation, we'll try to understand the basic background and the basic features of Virtual Labs. And once we are done with the presentation part, then we'll switch to the demonstration part where we'll see the different experiments, and we'll understand and we'll learn that how as a user we can explore these experiments virtually. And at the end of the session, if you have any queries, you can please feel free to ask. I request every participants to please make sure that they have muted their mic so that there should be no disturbances while the session is going on. Great.
Biomedical engineering and biotechnology engineering. SBPSU has been designated as Nodal Center for Virtual Labs by IIT Delhi in August 2017 under the subsequent directives issued by MHRD. Being a nodal center, SBPSU has offered a well-furnished, fully loaded computer lab for the use of its students to empower them with the quality education which is the mission of SBPSU. Furthermore, if we look at the figures of Virtual Labs report of the various sessions, that is July 2021 and December 2021, it shows a huge interest of students in using virtual labs. As per the submitted usage report, a total of 2,564 virtual lab experiments have been performed by the students of various departments. We also thank you, Tanmay Tarundas Sir, Outreach in Charge Virtual Labs IIT Delhi, for giving us this golden opportunity to have a tie-up with IIT Delhi for enhancing the practical skills and knowledge of our students. I would also like to express my sincere thanks to resource persons of today's session for taking out their time out of their busy schedule to join us here. Now, I would like to hand over the session to our today's resource persons, Mr. Prateek Sharma sir, Senior Field Engineer, and Mr. Shubham Dayal sir, Field Engineer, for sharing a demonstration of the virtual labs. Over to you, sir.
Thank you, ma'am. So as discussed, so we'll be beginning with the presentation part. So let us quickly try to recall all the basic idea and the background features of virtual labs. So virtual labs are those kind of labs which are not physically present, but they have the same characteristics, same attribute as those of physical labs. So in short, we can say that whatever the users they observe in their physical labs, Same thing will be, they will be able to observe over here as well on this particular platform. Indeed, one of the great initiative by the Ministry of Education that was earlier known as MHRD. So basically, why do we thought about this particular platform? Because what we observed way back that the students, they were very good in theoretical concepts, theoretical knowledge, but they were unable to gain an upper hand on the practical knowledge part. Means their practical skills were not up to the mark. So we thought that we will do something so that the practical skills could be enhanced, and that was the moment when this particular platform was, the idea of this virtual lab was thought, and it came into existence. So wherever the users are, means across any geographical location, they can have an access to all these good quality of labs that we have developed, and everyone has an equal opportunity to learn out from the good labs and to increase their knowledge level. Now, if we talk about the features of virtual labs, the best part is that these labs are available 24/7. So these labs can be accessed by the user at any time, at any point of day. What they require, they just require a system and a working internet connection. So if they have these two things, they can easily use all these labs. Also, adding to that, these labs are totally free to use. So as a user, you do not need to pay anything in order to access these virtual labs, not even a single penny, right? So the main highlights are that this particular platform is developed in self-learning mode. So as a user, especially as a student, if you want to learn and understand a particular concept on your own, this particular platform is very beneficial for you because it has been designed in such a way that you learn the things out on your own, and you'll be also able to evaluate that how much you have learned and how much you have understood. Also adding to that, we have this innovative experimentations part. So there are certain things which the users, they cannot perform in the physical scenarios due to various constraints. So all those things can be overcome and can be performed over here on this particular platform. So it supports the innovative experimentations part. So till now, more than 100 virtual labs have been developed, and each virtual lab consists of at least 10 to 11 experiments. So cumulatively, you have more than 1,000 virtual experiments to choose from and to learn from. Now, this slide tells you the motivational part, that why and what motivates the user to take up this platform. So the very first one is the physical distances. So there are certain scenarios in which the users, they are unable to attend the physical lab lectures. So there's a distance between the user and the lab. So this particular distance would be bridged by this virtual labs platform. Next, we have these costly equipments. So what we have done using this particular platform, we have made sure that the costly equipments are shared individually to each and every user. As a result, they have the complete freedom and they can perform the experiments in whichever way they want to perform. Lastly, we have proliferation. So by proliferation, it means a regular increase in the quality of labs. So what you'll observe while performing these experiments, that on a single concept, you'll find different labs developed by different institutes. Then you would be getting a diversified content, and that will help you to learn in a better way. Now, this is the basic idea, and it is very easy to understand and correlate. So we have these virtual labs. So as a user, you require a system and a working internet connection. And if you have these two things, basic things, you can easily have an access to all these labs that we have developed. Moving on to the objectives. So these are the certain objectives of the virtual labs platform. So again, as we are discussing from the starting point, that we wanted that the users, they should be able to remotely access the labs. Means wherever they are virtually, they should be able to see how the experiments can be done. And so we have made sure that the remote access can be provided to the users, especially to the users or the domains of science and engineering. So more of the labs you see on our platform, they try to cater the students of science and engineering domain. Next, we also wanted to provide the students everything at a single click. So everything required by the user would be present over there at a single click. Third one is that this particular platform does not have any time boundation. So, for example, contrary to your physical labs where you have time boundation, on this particular platform, there is no time boundation. You can take as much amount of time you want, and you can learn at your own pace. So lastly, we call it as a complete learning system because we have added certain extra features, additional features like the web resources, the animation, and the web lectures. So that is why we call this particular platform as a complete learning management system. So these were the objectives. Now, this slide tells you the difference between the physical labs and the virtual labs. So you can see there are various factors like cost, availability, experimentations. So just imagine, try to, quickly imagine the physical lab, you need to have a purchase the equipments and everything, but for virtual labs, almost nil availability. Physical labs are available for a particular period of time, but virtual labs, anytime. Experimentations part, Of course, not everything is, we are, as a user, we are not allowed to do everything in the physical scenarios due to safety concerns. But on virtual labs, virtually we can do that. Lastly, we talk about the user experience. So we say that, look, virtual labs are there, but physical labs still holds the best user experience because they give you the real-time hands-on experience, which the virtual labs cannot provide. But yes, using virtual labs can enhance your efficiency in the physical labs. So once you start exploring these labs, you will find these three different category of labs where we have modeling-based labs, where we have just created a replica of a real-life scenario. Then we have this measurement-based labs, where what we have done, we have made sure that all the numerical values, numerical observations that are required by the user, they should be present over there. And the last one is a remote trigger one, where what you can do, you can trigger a particular setup which is very far away from you in the real time. But yes, these remote trigger labs have a certain constraint that at a single time, only a single user can have an access to them. These labs are not scalable. Talking about the intended users who all can take advantage out of this particular platform. So you see, anyone who has a will to learn, they can simply go and explore the things out over here. So these are the participating institutes. IIT Delhi is the main coordinating institute. Then we have the other 6 IITs and other esteemed institutes. So your university is a nodal center under IIT Delhi. Now, these are the different domains in which virtual labs, they have been developed. For example, you can see we have physical sciences, then we have this electronics part, CSE domain, electrical, mechanical, and so on. So how you can reach to this particular platform? So if you want to reach to the particular platform, you need to remember the website, that is www.vlab.co.in. So simply type this URL and then you would be having the website. So quickly recollecting what we have about virtual labs, the main highlight points: on-demand labs, whenever you feel like labs are there for you, then everything is present a single click. Self-evaluation, to support self-learning mode, we have quizzes. So you need to answer these quizzes so that you can evaluate. Animations, actions, they have a louder impact. That is why more and more animations they have been added. And lastly, you can commit any mistake on this particular platform without hurting yourself or without damaging the equipment. So these are the key highlight points of the virtual labs platform. So in the upcoming slides, quickly we'll see certain statistics, certain figures. So we see this is the national labs. Virtual labs have all across the nation in terms of our workshops. So similarly, you can see these labs are also present over there in the model curriculum. Yeah, for effectiveness, I would request that you should. I hope that the Santwa Bhakti is already making sure that all the students are performing regularly. But still, if you are not performing them, you should perform them. So that was the basic idea about virtual labs. And just in case you want to share something, we have the support credentials, support@vlab.co.in. You can simply put a mail to us, and you can also call us on the official number that in the official hours that we have mentioned. So now we'll quickly go and we'll see how these experiments they can be explored. So with me, I have one of my team member, Mr. Shubham. So from here, he will take on you and he will make sure that you understand the different experiments from the different domains. Like we'll see 1 or 2 experiments from the applied sciences, okay, and then we will also see experiments from the EC part. So over to you, Shubham.
Okay, thank you, sir. Now we'll be processing further to see some of the experiments that are available, let's say in electronics and communication domain and in physical sciences domain. And for that, let me just share my screen. I think it is visible now. Okay, so we'll just quickly move on to the virtual labs tab. And you can see if you go down the menu, we can see that there are broad areas of virtual labs that are electronics and communication, computer science and engineering, electrical engineering, mechanical, chemical, physical, chemical sciences, biotechnology, or civil sciences, civil engineering. We can go into these, any of the domain, and we can then go to the any laboratory to perform our experiment that are mentioned in that particular laboratory. So for now, we'll choose the electronics and communication domain. When we go into the electronics and communication domain, we can see that there are various laboratories that are available. These laboratories are laboratories that are ready for use, and adjacent to them, you can see the institute that has developed this particular laboratory, like the feeding channels and mobile communication laboratory is developed by IIT Kharagpur, Hybrid Electronics Laboratory is developed by COE Pune, and so on. Thereafter, you can also see that there are some upcoming labs that are in this particular website. These can be used, these can be experimented, but there might be some bugs. You might find one or two bugs, and in some cases you might not be able to perform the experiment. But in any case, you can definitely go to the theory part. You can know this particular experiment, and you can perform or know about this particular experiment. And whenever that lab is available for use, or if you are performing in the in your laboratory, physical laboratory as well, you will know the basic idea of how the experiment is being performed. So you can see that there are various laboratories that are available. So we'll just quickly go on to the digital electronics circuits laboratory. And now you can see this is the interface of this particular laboratory. First is introduction, which introduces the student about this particular laboratory, the type of experiments you are going to perform, and the types of aim that you are going to perform in this particular laboratory. Thereafter, you get the people. The people those are involved in making of this particular laboratory. Thereafter, you have got this technology used, which says that Flash player JavaScript and jQuery has been used to develop this particular laboratory. Then we go to the list of experiments. It mentions all the list of experiments that are available in this lab. Every single lab has at least 6 experiments. In this particular laboratory, we have got 10 experiments. So we'll just quickly move on to the, let's say, first experiment, that is analysis of functions of BCD to 7-segment decoder driver and operations of 7-segment LED display. When we get into this particular experiment, you can see the interface. You can observe that the interface is very much similar to the one you get in your laboratory manual. That is, first is introduction, thereafter you have got theory, then you have, which will brief you about this particular experiment. You have got the objective part, thereafter you have got the procedure, simulator, quizzes, references, etc. So the introduction mentions that after performing this experiment, the student will be able to display decimal numbers 0 to 9 on a 7-segment LED display, will be able to display a blank, will be able to use the inputs like LT, RBI, then we'll be able to blank out the leading zeros in a multiple digit display. After the introduction, we go to the theory part, which very clearly mentions in details about this particular experiment. Everything, if you know this particular experiment, you can go into the theory part and revise this particular topic. It is shown by this experiment, no problem. Every single detail that you should know to perform this particular experiment. Like you can see, first is the representation of a 7-segment display, that is from A to G, and thereafter you can see the type of input we give. Accordingly, we get the output. Suppose we have given high input to B and C, we will get 1. If we give high input to F, B, G, and D, we will get 4, and so on. Thereafter, you can see that this particular experiment can be performed with either common anode or common cathode. In this experiment, we have used common anode. Some theory about that. Then we have this pin values of 7447 ICs. Then we have got this truth table that is used in digital electronics, and so on. You can go to this theory part, and when you are prepared, you think you are prepared, you can go to the further process. That is our objective part, which again says that the aim of this experiment is to fully understand the function of a BCD to 7-segment decoder and use it to control the operation of a common anode 7-segment LED display. Thereafter, we have got the procedure part, which tells you step-by-step process that we are going to follow in order to perform this experiment. This particular experiment is in part 1 and part 2. You can see that there are 4 steps that are required to perform this experiment in part 1, and there are 5 steps required to perform this experiment in part 2. Without wasting time, we'll go to the simulator part. As I mentioned that there are 2 parts, so we have got these 2 menus, part 1 and part 2. We'll click here for JavaScript simulator for part 1 experiment. Now here in this interface, you can see that to the right we have the 7-segment display unit, and to the left we have 7447 decoder IC. Thus you can see A, B, A to G, we have the output of the IC, and suppose and simultaneously we have the input for the display of the 7 segment display. When these A, B, C, D are the input pins, the kind of input we provide on A, B, C, D, we get the output on these A to small, which are represented as small letters from A to G. But suppose I provide some input to B, let's say suppose C as well, we don't see any output. That is because there are some functional keys here, and you can see LTRBI, without which we will not be able to perform the experiment. To perform this particular experiment, we must know the rule of how to perform this experiment on decoder IC, how to use this IC. So for that, suppose if I give high input to LT and low input to BI and RBI, do I get a output? No, I don't get an output because to perform this experiment, use this IC, I need to give inputs to BI, high inputs to BI and RBI as well. Suppose I don't give high input to LT, will I get the desired output? I must have got 1, but I have got 0, nothing. So I have to give input to LT as well. So as I've given high input to A, I get 1. If I need to give output, if I need to see output as 2, I'll give high input to B. If I need to see 3, I'll give high input to A and B, and so on. We can perform this experiment. Thereafter, we'll just close that tab and we'll go to the part 2. We have part 1 was the basis of how do we use the 7447 decoder IC. Thereafter, we'll go to the part 2, where this is a cascade form of the experiment that we have performed in part 1. You can see the ICs 7447 are cascaded to one another. It can be 2 or more than 2 depending on the depending on the number of outputs we want to see. And you can see that we have got common grounds here, and we have got the common VCs here, and the one IC is connected to another IC through the BI and RBI port. And whenever I give input to this IC, I see some output. But what about these 2 ICs? Suppose if I don't want to see output on these 2 ICs, I can switch them to 0. But suppose if I want them to be switched on while I'm performing the experiment, what I should do? What I should do is that I should give high input to RBI pin of the last IC, of the first IC, or you can say. When I give the input to RBI, I can see that all the 3 outputs are lit up. And whenever I give any output to any of the ICs, the corresponding LED display is showing me the output. Let's suppose 3 for here. Okay, so there are some more functions that you can perform while giving different inputs to different functional pins, and you can know this particular experiment well. Now we have performed the second part of this experiment as well. We'll move on to the next part, that is quizzes. Now since we have gone to the experiment, we must be knowing, it is expected out of you that you must know, now you know about this experiment. So you have the quiz part, wherein there are some questions that you can answer. Let's suppose I'm giving the first answer. What displays is used in portable digital devices such as watches or solar powered calculators? I think that is LCD, liquid crystal display. So I'll just mark this question, answer, and then go into the submit part and know whether my answer is right or not, right or wrong. That is right. So I can answer all these questions and then I can check my knowledge. If I miss out on 1 or 2 questions, I can go back again to the theory part, perform the same experiment any number of times till I'm satisfied with myself. Suppose if you want to go further, you want to dig a little further in this particular topic, these are the references that are given to you. You can use these books and you can dig further into this particular experiment, and you can know in much deeper details about this particular experiment. We'll just close on to this tab and we'll go to the back menu of Electronics and Communication Lab, and we'll perform some other experiments. Let's say Ohm's law. Okay, before that, I'll just mention one more thing here. We have got this feedback part here. Suppose you like this experiment, you can give your feedback in this format. You can give us the details, And if in case you think that there is need for improvement, there can be something that can be improved, you can give us that feedback as well, and we'll definitely look into it to improve your user experience further. After this, we'll go to the main menu, and we'll go into the basic electronics lab to perform experiments that are supposedly in this particular laboratory. This laboratory is developed by IIT Kharagpur, and you can see again the first is introduction, which introduces you about this particular laboratory. Then we have the list of experiments, which contains the list of experiments in it. Then we have the instructions part, the instruction that you must follow while you are performing experiment of this particular laboratory, technology used, people associated with this particular laboratory. Then we have got the feedback part. Let's go to the experiment part. You can see that there are a lot of experiments that you can perform. There are 17 experiments. So from this, let us go to this Ohm's law. Again, the interface is very much same to the practical lab manual that you have in your laboratory. First is theory part, which explains that after this experiment, the student would be able to explain what is Ohm's law for resistance in series and parallel, will be able to know how non-ohmic devices function, and then with all the readings that you will be having, you can measure and confirm the Ohm's law, the working of Ohm's law. This is the theory part, which describes Ohm's law, the triangle that is associated with the variables that are there in Ohm's law, like V equal IR. These are the variables and how they are related to each other. These are the explanation of Ohm's law from a very basic circuit. Then we have Ohm's law for resistance in parallel. This is the explanation part of what we are going to perform in the experiment for series. Then we have for parallel. Similarly, we have for non-ohmic device as well. You can go through this theory part in order to get familiar with this experiment and to perform this experiment further. Thereafter, we have got the procedure part, which tells us step-by-step process of how we are going to perform this experiment. First is to confirm the Ohm's law. Thereafter, we have confirming the Ohm's law by series in resistance, by series in parallel for ohmic device, non-ohmic device as well. When you have read this procedure part, you can go into this simulation part. As I mentioned that there are various parts of this particular experiment, like first is Ohm's law draw circuit in resistance series, non-ohmic device as well. You can do two things. You can directly verify the Ohm's law, like clicking on this. You have got this circuit directly already built for you, or you can draw the circuit as well. Let us take this Ohm's law for resistance in series and let's just draw circuit by ourselves. What we need to do is we need to connect this circuit according to what is defined already. So as it is Ohm's law in series, so I'll just connect the resistances in series. I'll connect the potentiometer in parallel to the resistances, and we know that ammeter is connected in series with the resistances. So I'll just connect the ammeter in series. Now I'll click on the check connection to check whether my connections are right or wrong. It says the connections are right, so I'll just proceed further. I'll have to first give some DC volt to this particular circuit. Let's say suppose 6 volt I've given. Thereafter I'll just give some resistance value to this circuit. Thereafter, what I need to do is I'll just I'll just add this to table. And you can see to the left is the readings. 5 is the voltage that I have given. Current calculated is 0.238, and you can over the above you can see the resistance R1 is 14, resistance R2 is 7, and since these resistors are in series, so we get the equivalent resistor at 21 as the resistance in series directly just add up arithmetically. 14 plus 7 equal 21. Thereafter, I'll change the DC voltage, and you must know that for ohmic devices, the resistance doesn't changes. So we'll have a constant resistance throughout this particular experiment. While you're performing this experiment, we'll add this to table. We'll take some more value. Minimum is 3. As we know that to plot any graph, we need to have at least 3 values. We'll just add to table. We'll just change the DC voltage. Let's say suppose we have taken 4 readings. When we have taken 4 reading, we'll plot this particular graph, and you can see the graph is a straight line which tells that we have verified the Ohm's law. Now we have since we have the graph, we can also save it as either as PDF, or we can take the printout of it so as to paste this graph in our practical notebook. Thereafter, either I can delete the connection and I can rebuild the connection, or I can just close this tab. I can just go back, let's say to the normal. I will just take one more example of verifying non-ohmic devices. Here the connection has already been made, and we know that in a non-ohmic devices, the resistance of the particular device changes, but the volt will be same. So we'll have a constant volt throughout the experiment, and we'll be changing the resistances. We'll set the DC volt to 5. Whenever you do something wrong, which is not how you must perform the experiment, it will tell you to correct yourself. So we have given the DC volt as 5. We'll add this to table. We'll change the resistance value. We'll add this to table. We'll change this resistance value again. We'll add this to table again as well. We have got at least 3 values. So now we can plot this graph, and we can see that there is a slight difference from about the graph, which says that yes, the V and current and voltage are not directly proportional to each other. They varies accordingly. So it is very much clear that for non-ohmic devices, the Ohm's law is not followed. You can take the printout of it, and you can paste it in your lab manual or lab copy. Now we have performed the experiment. You can perform other experiments as well, other parts of this experiment as well. Thereafter, we get to the quizzes again. We have got this quiz. You can answer these questions, and you can then check your knowledge, check your understanding about this particular topic. After having the quiz, we can go to the assignment part, which again give you some more questions, some numerical questions to check your knowledge about how better you know this particular experiment. If you are unable to answer these questions, you can either go back to the theory part and then procedure and again go to the experiment, or else you can ask your teacher. And even if you don't have the two options, you can go to the references part. You can go to these video lectures that are provided here, and you can refer to these books so as to know this particular topic better and clear your concept in this particular experiment. Now we'll just quickly see one more experiment from this particular domain, that is electronics and communication domain. Just a second, guys. Let's go to the analog signal network and measurement lab that is again developed by IIT Kharagpur. Again, the same interface. We'll just quickly go into the experiment part. You can see that there are subtopics in this particular laboratory. Like first is basic electrical technology laboratory that are for all UG students for all disciplines. Then we have this these experiments are for experiments in section B are for students of EE, EC, CSE and IN background. We can go into any of them. Let's say suppose we have this verification of Norton theorem. You can see the theory here which states about the Norton theorem, and you can see that there is a diagram of a common circuit. Thereafter, we have reduced this particular diagram. We'll be reducing this particular diagram step by step as you do while you are solving the question into a Norton equivalent circuit. This is the Norton equivalent circuit where we have Norton current, where we have load current and Norton voltage. After going to the theory part, we can go to the procedure part. which tells you how you are going to solve a complicated circuit and breaking down it into a Norton circuit. These are the variables. These as you can see that they are the circuit is a kind of variable circuit, where you can see you need to change the type of like if it is a short, you need to sometimes do it to open. Sometimes if it is open, you have to go to make it short. So this is how you're going to proceed in this experiment. You can go to the procedure part. You can understand this particular experiment. Then we have the operating environment, wherein you can see that there are the system requirements that your system must follow in order to perform this particular experiment. We have made the experiment in such a way that the requirements are pretty much very normal. Every single systems nowadays can perform the particular experiment, so you won't have any problem in performing the experiment, and you can perform this experiment with your personal computer or laptops as well. Thereafter, we go to the simulator part, and we'll click on the simulator part. You can see that we have the circuit here, and we also have the circuit mentioned for your reference if in case you forget something or you want to check something. In this particular circuit, you can see that we have variable, like we can vary the input voltage, we can vary the resistance 1, R1, R2, R3, R4, we can vary the V2, and so on. We have got this variable options where we can power either short or either use intermediate. This also we have power, load, and short as our option. Now we have gone to the procedure part. So the case one says that case one will be solving the particular experiment by our normal method. We will be using Norton's theorem to solve this particular experiment in the case one. So case one say that we need to switch the S1 to power, which is already in power, and we need to switch the switch to load. We'll switch it to load. And when we are done with that, we will simulate and we'll get the load current value. If we go down below, we can see that there is an observation table, but the observation that we take will only be visible to us once we have completed this whole process of case up to case 3. So meanwhile, you can note down this value in your lab manual. This load current that we deduced is deduced on the basis of the normal procedure that we use. This is not according to the Norton's theorem. So now in case 2, from case 2, A, B, C will be using Norton's theorem to deduce this particular problem. So in this, it says the S1 to power and S2 to short. We'll short this, and we just simulate this. If you observe and if you have done if you have done some numericals based on this Norton's theorem, you would know that we are going step by step exactly as what we do while solving a numerical. So now we have got the Norton short circuit current, that is ISC 0.67. In case 2, we'll calculate Norton resistance. So for that, it says that we need to switch it to S1 to short and S2 to power. By this, we will get the voltage and current, and by using V equal IR, we can calculate the Norton resistance. We have got this Norton resistance, and we proceed further to case 3. We have got this. You can see that we have the equivalent Norton circuit where we have Norton current, that is short circuit current. We have Norton resistance. We have a load current value, which will help us to calculate the load current. And you can see that if you have written down the value which we got in case 1, which is just similar to what we got in case 3, that means we have verified the Norton's theorem, and thereafter we can fill this data to the table. It says the observation table is updated, and now we can change the resistance and voltage value and take other observation by making other circuits. You can see that observation is already been filled. You can change these value, like suppose R to 50, R3 to 100, and so on. You can also change the voltage, and you can perform the experiment by taking observation 2. After we have performed this particular experiment, again we have the same thing as quiz, which tells you how much you know about this particular topic. So we have got this some numerical here. You can solve these questions, and if you get stuck somewhere, you can either go back to this theory part. You can perform the experiment again. You can ask your teacher, or you can go to the reference part, and you can know the book name and the video lectures. And you can go to the video lectures and see the video to understand the topic better. I think the time's up for now. So I'll just wind up and give back again to Pratik sir.
Thank you, Shubham. So I think well, most of the participants they have observed the different experiments that was demonstrated by Shubham. So just in case you have any queries, so what you can do, you can please put a mail to us on support@welab.co.in. And once you put a mail, so we would be very happy to answer to your queries and to make sure that you can utilize this platform in a much more better way. So with this, I think we would like to conclude this particular session. So if you have any queries, you can please quickly ask, or else we'll simply wind up the session. Thank you.
Uh, Good morning, everyone. We will be going to start our second session after 5 minutes. A very good morning to one and all. I welcome you all for the second session of Virtual Lab. Sir, shall we start our second session?
Yes, ma'am, please. Please let me know when to start.
Fine. Thank you so much, sir. So we will be starting within 1 or 2 minutes because maximum students have joined now and have sent the links to other classes also. They will join side by side.
Sure, ma'am, no issues.
Fine. Thank you so much, sir. We'll go for the second session. I request Prateek sir and Shubham sir to please start the second session of today's virtual lab workshop.
Thank you, ma'am. So first of all, a very good morning to all the participants present. Greetings from Virtual Labs IIT Delhi. My name is Prateek Sharma, and today me and my team from Virtual Labs IIT Delhi, we will let you know about this particular platform. So let's see how the session will proceed. So first of all, we'll see a small presentation. We try to understand what Virtual Labs in this presentation. We'll try to understand the features of Virtual Labs, what is the background, and how it would help the users to enhance their practical skills. So the very first thing is that virtual labs. When you hear about virtual labs, it is clear that these labs are virtually present. Means these are not physically present labs, but yes, whatever observed in the physical lab scenarios, same thing will be observed by you over here as well. It is an great initiative by the Ministry of Education, and this platform comes under the project of NMEIT. So we introduced this particular project because we observed that the students, especially the students from the science domain, they were somewhere left behind in the knowledge. Theoretically, they were knowledge was so that we will develop something so that the practical skills could be. So we wanted that wherever the users are, wherever they locate all across India, should be able to have an equal opportunity to learn, and they should also be able to have the good access to the good quality of lab. So this platform provides them all those things, and as a result, they can learn and enhance their practical skills using this particular platform. Then we talk about that this platform totally free to use. You please be careful. This platform is totally free of cost. Okay, as a user, you do not need to pay anything on this particular platform. What you require, you just require a system and a working internet connection. If you have these two things, you can easily access all these virtual labs that we have created. Now, we also say that this platform is developed in self-learning mode. Now, we say that because we have designed this platform in such a way that a user, especially a student, can learn and understand a particular concept on their own without even dependencies on the other factors like the faculty members or the lab instructors. Next, apart from that, we also say that it supports innovative experimentations part. Now, you see, there are certain things which you cannot perform freely in the physical lab scenario due to various safety concerns. Okay, but all those innovation, all those innovative part can be observed over here on this particular platform. It allows the user to go out of the box, try something new so that they can see what is the output of their curiosity. So till now, more than 100 virtual labs have been developed, and each virtual lab consists of at least 10 experiments. So cumulatively, you have more than 1,000 virtual experiments to choose from. So these were the features of Virtual Labs project. Now let us see why we should use this particular platform. So the very first one is the factor is the physical distances. Now there are certain times in which we are unable to attend the physical lab lectures. So there's a distance between the user and the lab. Now this particular distance is overcome by Virtual Labs project. Okay, because Virtual Labs make sure that the users they sit safely at their place and remotely they are able to perform the experiments. Next, we have sharing of costly equipments. So we have also made sure that the costly equipments are shared individually to each and every user. Okay, so as a user, if you start performing experiment on virtual labs, so these labs will be totally dedicated to you, and you can perform the experiments in whichever way you want to perform. Lastly, we have proliferation of quality of labs. So when we talk about the proliferation, it means a regular increase in the quality of our labs. So you'll observe that on a single concept, we would be having 3 to 4 different virtual labs developed by different institutes. Now, those labs will give you a diversified content and will help you to learn in a better way. So these are the 3 factors that will motivate you to take up this particular platform. Now we are seeing the basic idea. As you see, you can easily understand that we have the labs. These labs have been created and have been hosted on the cloud, and you are the remote users. What you require, you just require a system and a working internet connection, and then you can easily have an access to all these labs. So if we go for the objectives part, so these are the objectives which the virtual labs try to fulfill. So what are these objectives? The very first one is to provide remote access. Please again understand, we want that wherever you are, if you have a system and an internet connection, remotely you should be able to have an access to the labs that deals with science and engineering. Next, we want that everything which is required by the user to learn and understand a particular concept should be present over there at a single click. Third one, and the very advantageous point of this particular platform is that there is no time window. See, once you enter into your physical labs, you have a particular time window. And in that particular time window only, you need to perform the experiments, you need to take out the observations, and you need to submit your files. But that particular time is somewhat not sufficient for each and every individual. So on this particular platform, we do not have imposed any time constraint. As a user, you can take as much amount of time you want to learn the things out. Lastly, we say that this particular platform is a complete learning management system because we have added certain web resources, certain animations, certain videos. So it would be a kind of an interactive environment over there. So these were the objectives of this virtual labs. Moving on next. Now, in this slide, we are differentiating the virtual labs from the physical labs. So we are considering certain factors. For example, if you just try to set up your own physical lab. So for that, you need to have a certain amount of monetary funds with you because you'll purchase equipments, you need to have a space. Also, then apart from that, that particular physical lab will not be available to you every time because you cannot enter, you cannot have an access to the physical labs at every time. Also, there would be certain constraints because you cannot do anything in the physical labs due to various safety concerns because there might be a scenario where you might get harmed or the equipment would get damaged, right? But apart from that, on the contrary part for virtual labs, you see, there is no cost involved. You just require a system and working internet connection. These labs are virtually created, so they are available for you 24/7. Also, you can go out of the box. You can try something new in the virtual labs because you see, there would be no safety concerns because everything you are performing, you are doing it virtually and you are just observing the output. But yes, if we talk about the user experience, we say that, look, virtual labs have the second best user experience and physical lab is the best. Because the real-time hands-on experience that you gain in the physical lab, nothing can beat that. Okay. Then we have these 3 different category of labs. So the very first one is the modeling and simulation-based labs. So these are those kind of labs. I would request participants to please make sure that you have muted yourself. Right. So we have modeling and simulation-based labs in which what we have done, we have just simply created a replica of a real-life process, right? For example, observing a waveform on a CRO, observing a color change in acid-base titration. Next, we have measurement-based labs. Now, measurement-based labs are those kind of labs in which, as a user, I require exact numerical values, like the exact amount of current flowing through it, the exact amount of voltage. Lastly, we have this remote trigger lab. Now, remote trigger labs are those kind of labs in which a user, which is sitting very far away from a particular setup, can trigger that particular setup remotely in the real time, right? And in the real time, you can see how the equipment works, how are what are the different observations or the outputs that you are getting. But yes, these remote trigger labs, they have a particular constraint that these remote trigger labs, they are not scalable. Means at a single time, only a single user can have an access to that. Whereas the modeling-based labs and measurement-based labs, these are scalable labs. Multiple users can use them simultaneously. Next, we have the intended users. So anyone can use and utilize this particular platform, whether you are a college student, high school student, even the different engineering institutes. We have the resources, you simply utilize them and enhance your practical skills. Then we have these participating institutes. So IIT Delhi is the main coordinating institute, and your university is a nodal center under Virtual Labs IIT Delhi. Now, these are the broad areas of virtual labs. So these are the different domains in which virtual labs they have been covered. So starting from the very basic one, we have physical sciences, chemical sciences. Then going on further, we have electronics, computers, mechanical, and so on. Now the question arises that how you can have an access to all these labs. So in order to access all these labs, you need to remember the URL, that is www.vlab.co.in. I request all the participants to please make a note somewhere. Okay, remember this particular website, that is www.vlab.co.in. This is the only website that you need to refer, and you'll find all those more than 100 virtual labs present over here on this website. Now, quickly highlighting the points or quickly recollecting what we have learned about virtual labs till now. So we have these labs on demand. So whenever you feel like, labs are there for you. Next, we have everything present at a single click. Third one, so you'll find certain set of questions after each and every experiment. Now these have been added so that you could evaluate yourself, right? So to support the self-learning part module, so we have added certain questions, self-evaluations or certain quizzes. So you'll answer those quizzes and you'll be able to evaluate yourself. Then obviously we have these animations because actions, they have a louder impact. So that is why we have added more and more animations over there. Lastly, freedom to make mistakes. So as a user, you can commit any mistake on this particular platform without hurting yourself or without damaging the equipments. So we have just quickly recollected the main highlight points of this platform, that is Virtual Labs. So in the upcoming slides, we'll see the impact of the project. Certain statistics are there. Now you can see, as I told you earlier as well, that your university is a nodal center. So you are the designated and certified user of Virtual Labs. Then we have certain glimpse of our workshops. So how do we used to go for the in-house workshops, right? So those glimpses have been shared with you. Then AICT, also the AICT guys, they have also added virtual labs in their model curriculum, and you'll find the virtual labs over there as well. So most of the students are from, I can see they are from the very basic first year or so. So I would request that you please listen to us very carefully. We'll tell you the different steps that you need to follow and how you can effectively utilize this particular platform. And I also expect and I request the participants that once this webinar is over, you should perform few experiments on your own, because if you won't perform it on your own, you won't be able to have a good idea about it. So that was a basic idea about virtual labs. So just in case in future you find any query or you are unable to have an access to any of the lab, in that particular case, you can simply put a mail to us on support@vlab.co.in, and also you can call us on this particular number in the official hours. So that was the idea that would deliver to you with the help of a presentation. Now, what we'll do, we'll show you the different experiments that we have, and we'll show you the various ways by which you can have an access to those particular experiments. So with me, I have one of my teammate, Mr. Shubham, and from here, Shubham will take you further and will tell you how those experiments can be explored. So over to you, Shubham.
Thank you, sir. Thank you for introducing the students to Virtual Lab. So to proceed further, I'll just share my screen, and from there on, we will be taking upon some experiments to know better how to perform the experiment on Virtual Lab. I think I am audible, and my screen is also visible. So we'll just go on to the home of our virtual lab, and if we go down below, as sir has mentioned, we can get the domains here. Like we have electronics and communication domain, computer science and engineering domain, electrical, mechanical, chemical, biotechnology, civil, physical and chemical sciences. These are the domains under which laboratories are further divided. Thereafter, in those laboratories are the experiments that are further divided depending on the type of experiments you're going to perform. So we'll take up some experiments from the physical sciences. So I'll click on physical sciences. And here we can see that there are some labs that are ready for use. You can see here like molecular interaction lab. And adjacent to it, it is the it is the institute that has developed this particular lab. Like for this lab, it is IIT Hyderabad that has developed it. Solid State Physics Virtual Lab is developed by Amrita Vishwa Vidyapeetham. So accordingly, all the labs are mentioned and the developer are also mentioned adjacent to it. Apart from that, we also have some upcoming labs like Virtual Astrophysics Lab, Basics of Physics, Digital Anthropology Lab. The upcoming labs are not fully developed. They can be or cannot be bugs. So you can go through these lab if you want to perform the experiment which are mentioned, which are there in this particular lab. If you are not able to perform the experiment, no problem. You can go to the theory part, you can go to the procedure part, and you can get yourself familiar with the experiment when you to so that you when you perform in the laboratory, you don't have any problem. So we'll just take on some experiment from this laboratory. We'll just go into, let's say, electricity and magnetism virtual lab. So now you can see that this is the interface, and you can see these are the various experiments that are present in this particular laboratory. Every single laboratory has at least 6 experiments. Here you can see, I think there are 9 or 10 experiments. So we'll just go into one experiment and perform that. Let's suppose we'll take magnetic field along the axis of a circular coil carrying current. You can observe that the interface is very much similar, or the topics are very much similar to the one we get in our lab manuals. That is, first we have got theory part, which describes the particular experiment and the theory with respect to the experiment. Then we have got the procedures. Then we have got the experiment. Then we have assignment, reference, and feedback. So the theory first say the aim of this particular experiment, that is to study the variation of magnetic field with distance along the axis of a circular coil carrying current. Then we have got the apparatus. Then we have got the theory, which states the Biot-Savart law. Here is the diagram of Biot-Savart law, and thereafter derivation of the formula associated with this particular theory. Thereafter, you can see that there is a graph mentioning Biot-Savart law, that as the distance at the zero distance, the field is maximum, and as we go further from the initial point, the magnetic field line decreases. So after we have read the theory part, we have got familiar with this particular topic. We can go into the procedure part to know the process of how we are going to perform the experiment. To the right, you can see there is a diagram, the circuit diagram, which we are going to make in this particular experiment. So you can memorize it, and you can know how the experiment is going to be, circuit is going to be drawn. Thereafter is the observation table. You can see here. These you can note down in your practical practical notebook, and this will help you to write the observation that you have got from this particular experiment. Then you have got the procedure of how you are going to perform the experiment in this simulation. Then you have got the result that you need to mention in your lab notebook, which is very much similar. I think interface you can know, which is very much similar to the one you do in your lab notebook or lab manual. Before going to the simulator, we have this self-evaluation part for you to understand whether you know this particular experiment or not. You can answer these questions like magnetic fields are produced due to it is charge 1 Gauss equal 10 to the power minus 4 Tesla. You can answer these questions, and if in case there are some questions that are wrong, you can again go back to the theory part and prepare yourself for the simulation. Prepare yourself for the experiment. Then after going through all this process, we'll go to the experiment, that is simulation. And to the top right corner, you can see there is a maximize option, which will maximize the window. And you can see that there is this is our apparatus. These are the apparatus. First is ammeter, then we have commutator. We have commutator. This is battery. This is ammeter. This is commutator. We have this coil, magnetic coil, rheostat, and the key. So before doing anything else, we need to do the initial adjustment. We'll take you to the maximized version of the compass needle. So what you need to do is you need to align this compass to the magnetic meridian. For that, we'll just rotate the compass and make it parallel to the magnetic meridian. For smaller adjustment, you can also use the scroll buttons in your keyboard. And after that, we need to align it to 0 degree. We need to make our compass to 0 degree. We'll use scroll buttons to do minor or small adjustments. Once we have done this, we can go to the we can go to the apparatus view, and now we can draw the circuit diagram. We can connect the circuit. So I'll just connect the battery to the key. Thereafter, I will connect the ammeter to the commutator to the coil, and commutator again to the rheostat. For the completion of the diagram, for the circuit, we'll just connect the rheostat to the key. Then we'll just insert the key to close the circuit diagram. Now you can see that the variables which were present earlier, but we weren't able to select them. We can select them right now. So I'll just take some number of coils, turns of coils, and then I'll just take a random radius of the coil. I'll adjust the rheostat, give some initial value, resistance value to this circuit. Thereafter, you can see that we have this compass position, that is, for now, it is 0 centimeter. As I move this particular variable, the compass will move with respect to the coil. So if I move to the left, it will go to the left. If I move to the right, it will go to the right, and so on. So we'll just take the first reading while the compass has it is at 0 position. We'll zoom compass. So you can see, we can zoom compass, and you can see some deflection in the compass, that is 44 degree and 45, close to 45 degree. Thereafter, that is theta 1 and theta 2. Thereafter, I'll just reverse the current, and I'll get some other values, theta 3 and theta 4, that are 45 and 45 respectively. Here in this particular experiment, by performing the experiment in virtual lab, you won't see much of deflection, as you can see in your laboratory, because the controlled environment is very much controlled here, and so you will get mostly the same readings. Once you have taken these readings, you can note down this to your table. Then you will just move the compass to some position, let's suppose say -3. So you'll get some deflection, that is 38 and again 36. Then you will reverse the current. It is 37 and 37 again. You can take this reading, you can take this reading at different positions, left and right, like +3 will be taking the value at +3. It has 36 and 36 will reverse the current. It is again 36 and 36. Taking as many, while we are taking so many, the reason why we are taking so many values of thetas are that we'll get a mean value, and which will reduce the chances of our having a reduce the increase the chances of having a better result. So we can also show the result. As we know, the aim of this experiment is to know the magnetic field. So this is the result by using. So as we have taken all the all the values, and we have written it in the observation table, we can calculate the Bx, which will help us to calculate the magnetic field, magnetic intensity of magnetic field at that particular position, and hence we can find the B naught, which is the aim of the experiment, and we have completed the experiment. After that, we have this assignment part, where you can see there are some questions which you can solve. There are the numericals, which will which will get you going into this particular topic, which will push you to dig deeper into this particular topic. And if in case you are not able to answer some of the questions, you can again go to the theory part, read again the theory of this particular topic. Otherwise, you can also go to the reference part. If still you are not able to follow on this topic, you can go to the reference part. You can see the links where you can click on the link, and you can read this particular topic from there as well. Some of the bibliography you can also refer to. Thereafter, you have got this feedback part, for which you have to log in. So what you need to do is you have to create an account first, in which you have to give the give some of the very normal details like email ID, your name, your age group, college subjects, etc. And you can, since I'm already registered, so I'll just log in. We'll just log in, and you can see the feedback page wherein you can give the feedback whether you like the experiment or not. If in some case you think that there could be some improvement in this particular experiment, you can tell us. We'll definitely look into it and we'll try to improve the user experience. After we have done this particular experiment, we will go on to some other experiment from Solid State Physics Virtual Lab that is developed by Amrita Vidyapeetham University. So here again you can see there are some list of experiments. So from this we'll select Hall effect experiment. First is again the interface is very much same. First is we have theory wherein we have the aim, that is by this experiment we will be able to determine the Hall voltage across the sample material, and we'll be able to calculate the Hall coefficient and carrier concentration of the sample material. We have got this apparatus that are being used in this experiment. Then we have got the theory part, which tells us about which gets us familiar with the Hall effect, what is Hall effect, and so on. Thereafter, we have the theory part. Thereafter, we have the diagram of Hall effect, explanation of what is Hall effect and how does it behave, which is that if a current carrying conductor is placed in a perpendicular magnetic field, a potential difference will be generated in the conductor, which is perpendicular to both magnetic and electric field. This is Hall effect. This is everything is mentioned. Everything about this particular topic is mentioned in it. So if you know about this particular topic, you can revise it. And if in case you don't know about the topic and you want to perform the experiment, you can come to the theory part. You can read it and you will know every single detail about it, which will help you perform this particular experiment. Next is procedure, which tells you the procedure that you are going to follow to perform this experiment. You have got this observation table that you can that will help you take the readings of the observations that you make. First is the relation between current through solenoid and magnetic field that is generated. Thereafter, you have this observation table for Hall effect experiment. This particular experiment has two parts in it, and the procedure that you are going to follow for this experiment, then the result. Before going to the simulator, we have the self-evaluation part, which again has some questions which you can answer to check your knowledge about this particular topic. If in case you are not able to answer some question, you can go back or you can refer to some other material to know the particular topic. Thereafter, we will go to the simulator part. We'll maximize the screen. And you can see the apparatus here. We have got two solenoids here. We have got an ammeter, a Gauss meter. And to the right, we have some variables which we can, we will be varying while we will be performing the experiment. And since we have two parts, first is magnetic field versus current, and the one is Hall effect setup. So you can either directly go to Hall effect setup, or you can first go to the magnetic field versus current to deduce a relationship between the two. So we'll just insert the probe and we'll just click on the wood so that it goes into the solenoid. So we know that as we increase the current value in the Gauss meter, we can see the magnetic field is also increasing. As I increase, which states the relationship between the two. Since we have done this and noted our observation in the observation table, we'll go into the Hall effect setup. We'll insert the Hall probe. You can see the Hall probe which has four wires connected, two for current and two for voltage. So we'll insert the Hall probe. We'll click on the wood so that our Hall probe is kept under the magnetic field. Now we can give the current to the circuit. Thereafter, we can change the thickness of our Hall probe. We can also select the materials of our Hall probe from germanium, aluminum, copper, or gold. Let's say germanium. We'll take germanium for this time. After, we'll just give some value to Hall current. And now I'll just click on show voltage, which will show us the voltage that is being generated due to the presence of Hall probe in the magnetic field. So you can also click on the show result, which will give you the value of Hall coefficient and carrier concentration. Formula for which are mentioned in the theory part, that is RH, which is Hall coefficient, equal to VH, that is Hall voltage into thickness upon I into B. So you can calculate the result by the observation you have, by the readings you have taken, and you can check, cross verify your result with the result that is already mentioned by this in this place. And now you'll just change the current, change the thickness. You can change this result, change this observation. You can then calculate again the result, and you will see that the whole coefficient is same, and carrier concentration is also the same, because these are the constant for any whole material. These constant will only change when I change the that particular material of the whole probe. So when you have done this, you can verify this particular experiment by the result that you have got, and thereafter you can go to the assignment part. You can do these questions and know whether you really know this a particular topic or not. If not, you can again go back to the theory. You can perform the experiment once again till you are satisfied. Thereafter, you go to the reference part, and you can go into any of these websites or any of these references books, which will help you to know better about this particular topic. Then you have got feedback. You can give us the feedback of whether you liked it or not. If there is some improvement, you can tell us. I'll just close this particular tab. Just go into the home page, and we'll just look on some of the experiments from the chemical sciences. So these are again the lab that are ready for use, and we have these institutes which have developed this particular laboratory. So for this, we'll just go into colloidal surface chemistry laboratory. Just took some experiment from this laboratory. Interface might be quite different from one another because labs are made by different institutions, but the purpose will be same, and you will see that there will be introduction about this particular laboratory, the type of experiments you're going to see in this laboratory, the objective of this laboratory, then the list of experiment, the target audience, that is the type of the students, the background of students that are going to need this particular laboratory, course alignment, and then the feedback. So we'll go on to the list of experiments. Again, you can see there are 9 experiments. Every lab has at least 6 experiments. So we will just go on to, like, suppose a demonstration of the surface effect of chemical properties of finely divided particles. We click on this, and you can see that we have got an interface which is quite similar to the one which we get in our lab manual. First is aim, then we have got theory, then objective, procedure, simulation, and so on. So it says the aim of this objective and the principle on which this particular experiment is based on. As we know that when we have very finely divided particles on the size of nano size particles, the properties of that particle changes, and the properties of the solution in which those particles are subtended also changes. So this will be the principle behind this particular experiment. Then we have got the theory part, which says what kind of experiment we are going to proceed. Like in this, the simple preparation of Ag colloid is chemical reduction of silver salts by sodium citrate or sodium borohydride solution. And for this particular experiment, there can be some more ways by which you can perform the experiment. But for this, we will be using the borohydride reduction method, which requires only addition of sodium borohydride into an aqueous solution of silver salt. And these are the chemical reactions and thereafter you will get the precipitation of AgCl and HgCl, which is our endpoint. Thereafter, we go to the objective, that is to observe and analyze the surface effect of chemical properties of finely divided particles. Thereafter, we have this procedure, which tells you how we are going to proceed into this particular experiment. You can go through it and get familiar with the experiment that you are going to face further. So here you can see we have the apparatus here, and to the top here you can see there is some instruction that is mentioned which will be guiding us throughout the experiment. So it says that click on the flask containing AgNO3, a solution that is 100 ml, as solution to place it on the magnetic stirrer and heater. So I'll click on the flask. Thereafter it says that we need to click on the magnetic bead for it to drop into the flask. Once the bead is dropped, we'll click on the heater knob to switch on the heater, and we'll click on the magnetic stirrer we'll click on the stirrer rod to switch on the magnetic stirrer. And when the magnetic field is introduced in that particular place, the magnetic bead will start moving so as to give a as to stir the particular solution. So while it is AgNO3 solution is heating up, meanwhile we'll click on the pipette so that the pipette is moved towards the beaker and we can connect our trisodium citrate solution. We'll click on the pipette to draw 10 ml of solution. We'll again click on the pipette to move it over the flask so that we can drop it. We'll just drop the trisodium citrate solution in the AgNO3. And you can see that there is a physical change, a visual physical change, that is the color has changed to golden. This is the physical change that you can see. There are some chemical and other physical changes changes in physical properties as well when we are using material of the size of nanoparticles. So I think we have got our aim. So click on the three buttons, that is menu. We'll go on to the next part of this experiment, which is assignment, and have some pre-assignment as well as post-assignment questions, which you can check out and know your knowledge level of this about this particular experiment. Then we have got this reference part, the references which we have taken for developing this particular experiment, and then the feedback which you already know. Moving further, we'll just go on to our last experiment of this particular session. That is, we'll just take it from Inorganic Chemistry Virtual Lab, that is again developed by Amrita Vishwa Vidyapeetham University. And again, from the list of experiments we have, we'll go on to the perform to acid-base titration. You must have performed this experiment in your earlier classes as well. So we have this theory part which says the objective, that is to determine the amount of substance in a solution of unknown concentration using various titration methods. Then we have got this theory about titration, that how titration works, what are the results in titration, what are the procedures, and all such things. We have got the endpoint and equivalent points. And it says the indicator of how we are going to indicate whether we have we are going to indicate whether we have performed the experiment or not, and all such things are mentioned in this theory part. Everything that you must know to perform this experiment is mentioned in this theory part. Thereafter, you have the procedure part, wherein it says the step-by-step process of how you are going to proceed further to do the experiment, and some of the formulae like N1V1 equal N2V2, which you are going to use to reduce the result of your experiment. Self-evaluation, again, have some questions for you to test your knowledge, whether you are capable enough to perform this experiment or not. You can take this self-evaluation and then move further to the simulation part. Again, to maximize the unit, I'll click on the maximize icon. So you can see you have got this pipette, burette, every apparatus in this menu, and you have got some variables here, varying which you will be performing the experiments. So you have got this titrant. You can select any titrant you want from hydrochloric, HCl, sulfuric acid, hydrobromic acid, or any other. Let's suppose we select hydrochloric acid. Then you can also select the titrate from the list of titrates that are mentioned here. We'll see the sodium hydroxide solution only. We'll change the normality of titrate. We'll take up some value of the volume of the titrate. Let's suppose you have taken 11. So we'll just, and also the indicator, we can also have different indicators, like I'll be taking phenolphthalein in this case. And you must know the end result of the phenolphthalein, of how phenolphthalein acts in acid and bases, so as to observe your observation. So I'll just start this, and you can see the solution has started dropping on the solution in the burette, in the conical flask, sorry. You can increase or decrease the speed of titrant just as we do in our physical laboratory by turning on the knob. When the solution will be colorless, I'll stop this experiment. That means the solution is now neutralized and we have got our reading. I'll just speed up the process. And now you can see the solution color of solution has changed to a transparent, that is white. So this is our end result, and the result is that we use 4.5 ml of titrant. So by using the formula of N1V1 equal N2V2, I can calculate the normality of the second solution. We can take two to three different readings and share it in our observation table, and can proceed further to the assignment part, where we have some questions that are related to the particular experiment you have performed, which will test your understanding of this experiment after you have performed it. Then we have got this reference part, wherein the books and websites are mentioned, and again the feedback part, wherein you can give the feedback whether you like the experiment or not, and if there is some change that can be taken place, that we can improve the user experience, and we will definitely look into it. Thank you for now, and I'll be giving back to Prateek sir for further process.
Thank you, Shubham. So I hope all the participants, they have observed that how these experiments they can be performed and can be utilized. So you see, we had this short moment of time with us, so we were unable to demonstrate each and every experiment, but we have tried to make sure that the variety of experiments that we have, we were able to demonstrate that, and we were able to tell you that how these experiments and how this platform can be utilized. So again, at the end, I would like to say that if you face any query at any point of time, you can simply put a mail to us on support@velab.co.in. And also apart from that, you can see our official numbers. You can call us in the official hours for any further clarifications or any of the queries that you have. So that was all from the team from Virtual Labs at IIT Delhi. So if you have any further queries, we would be happy to answer, or else we'll go with the closure of the session. Thank you, everyone.